All right. Now we're going to talk about radians. Now the word radian is like the word radius. Oh, all right. We got some smart people in here. So let's look at this. We have a circle. And if I draw the radius of the circle like this, okay, that's a radius, right? Okay. So the distance from the center to the edge is the radius. So let's say I just go like this and just go, well, the length of this is the same as the length of this, right? And then instead of having it go straight up, I wrap it around the edge of the circle. And I do a wrappy type of thing here, like that. I take this and fold it over down to there. So it wraps along the edge of the circle. Now, what that does, if I wrap it for the length of the radius, and I make an angle out of it, this angle is 1 radian of an angle. It's so many degrees or 1 radian. Okay? The size of that angle. So you kind of get that if we take this and wrap it down like this angle is 1 radian. Now, how many radians do you think there are in a circle? No. Close. 6 is really close.
7.
No.
8.
It's not a whole number. Oh, no. Okay. What? A little less than 6.5, but
6.2.
a little bigger than 6.2.
6.3.
A little smaller than 6.3.
6.28.
6.28? Yeah. Yeah, 6.28 something. Yeah. Yeah. Dylan Riedel just says 2 pi times pi. Okay. What is 2 pi? What is the formula that 2 pi is involved in? 2 pi over there. Look over there somewhere. Do you see 2 pi? 2 pi r. 2 pi times the radius is the... What is the circumference of a circle? The whole thing. I need better description of what is the circumference. It's the length of the outside of the circle, the distance around the outside of the circle, the perimeter of a circle. You could have said any of those, and yeah, you're good. So the circumference of a circle is 2 pi r. 2 times pi times the radius. So to figure out how many radians are in a circle, okay, well, there's 1 radian, there's another, there's another, there's another, there's another, there's another, with a little bit 0.28 yada 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 left over, okay? Because the circumference divided by the radius equals 2 pi, okay? So there's 2 pi radians in a circle. Now, how many degrees are in a circle? There's 360 degrees in a circle. So, if you have 2 pi radians and 360 degrees, I could say that if they're both that many in a circle, 2 pi and 360 are equal to each other. So 360 degrees is the same as 2 pi radians. Okay, so I know that in 360 degrees, there's 2 pi radians. So I should be able to go from degrees to radians and radians to degrees. So if I have a 45-degree angle and I want to change it to radians, I could use these two things to change it, right? So 45 degrees. Remember back in physical science when you did this over this, and what you're converting to goes on the top. What you're converting from goes on the bottom. Now, we just said there's 2 pi radians in 360 degrees. Now, how many times does 45 go into 360? 8 times. So you get 2 pi over 8 or pi over 4 radians. Pi over 4 radians is the same as 45 degrees. Now you say, well, why don't we just use degrees? Because we all know degrees. We don't know radians. That's something totally... Well, in calculus and other things, we use radians. Okay? So we have to learn radians. So in trigonometry, we'll use radians sometimes, we'll use degrees sometimes, and you'll get so good at radians and degrees that you should be able to go back and forth without any issues. But being that this is the first day you've ever seen radians, it's a little more difficult. Okay? All right. You know, if 2 pi radians equals 360 degrees, could we simplify this a little bit so the numbers are smaller? How could we simplify this? Divide them both by 2, right? So pi radians equals 180 degrees. So that's going to be our formula to change radians to degrees and degrees to radians. So if we have 200 and 260 degrees, and I want to change that to radians. Well, there's pi radians over 180 degrees. Now, if we divide them both by 10, I get 26 over 18, right? And divide them both by 2, I get 13 and 9. So it's 13 pi over 9. Most of the time when you write radians, you'll write them as fractions. You usually won't write decimals unless they tell you to write it in a decimal. But this is called an exact answer using pi. Okay. So let's take radians and turn them into degrees. How would we take radians and turn them into degrees? Instead of multiplying by pi over 180, we'd multiply by what we're converting to goes on the top. What we're converting from goes on the bottom. So if we're converting 2 degrees, 180 degrees goes on the top. Pi radians goes on the bottom. Now this is easy. Pi cancels the pi's. We just ate our pi's. They're gone. Okay? So you got 5 times 180 divided by 12. 5 times 180, that would be 900. 900 divided by 12. 75. So 5 pi over 12 is 75 degrees. Okay? Now, sometimes we'll want decimal answers, such as if we have 36.4 degrees and we're converted into radians, okay, and they say put your answer in terms of a decimal, You just take 36.4 times what you're converting to, pi, divided what you're converting from, 180. So then take on your calculator 36.4 times pi, hit the equals button, divide by 180, hit the equals button. It'll be a decimal answer with a whole bunch of decimals behind it. So if we round to 3 places, 36.4 degrees is how many radians? 0.635 radians. Okay. So some of these you can use your calculator for. It'll make it really easy. Others, you'll want them in fraction form. Okay. So that's the basics of radians. Now, coterminal angles. We had that last time. Okay. What's coterminal with a 120 degree angle? What's coterminal with it? What's another angle that's coterminal? 480 degrees, because they're how far apart? 360 degrees apart. And we could also go the other direction. What's 120 minus 360? Negative 240 degrees. Okay, those are coterminal angles. What's coterminal with 2 pi over 3? We can't add 360 because that's different units. Just like adding inches to meters, you just don't do that. Okay, and we're not going to convert 2 pi over 3 to degrees to find coterminal angles. We're going to leave it in radians. Okay, how far is it around the circle in radians? What's one trip around the circle? How many radians is that? Well, it's 6.28 something radians, but let's keep it in terms of pi. 2 pi. Okay, it's 2 pi radians. So what do we do here? We added 360. So what are we going to do here? We're adding 2 pi. Well, what's 2 pi over 3 plus 2 pi? Well, we can't add those because they don't have what? Common denominators. So we got to get a common denominator. So this is 2 pi over 3 plus what over 3? 2 is the same as what over 3? 2 equals what number over 3? 6 over 3, right? So we're adding 6 pi over 3 to that. What's 2 pi plus 6 pi? 8 pi over 3. So 2 pi over 3 is coterminal with 8 pi over 3. What's a negative 1 that is coterminal with? Well, you take 2 pi over 3 and subtract 2 pi, right? Which is 2 pi over 3 minus 6 pi over 3, which is negative 4 pi over 3. Coterminal angles. Okay? Let's do another one. Let's say we have 7 pi over 6. What's coterminal with that? Well, what do we add on? 2 pi. So it's 7 pi over 6 plus 2 pi. Well, 2 pi is what over 6? Because we got to get a common denominator. What over 6 is 2 pi? 12 pi over 6. Because 12 over 6 is 2, right? Make sense? So 12 pi over 6. Well, we get 19 pi over 6. That's coterminal. 7 pi over 6, 19 pi over 6 are coterminal with each other. Let's say it takes 7 pi over 6 and subtract 2 pi. So then we're subtracting 12 pi over 6, which is what? What's 7 minus 12? Negative 5 pi over 6. Coterminal angles. Okay. All right. One last thing. Twelve pi over 19. What quadrant am I if I'm 12 pi over 19?
3,
Close.
4,
No.
2.
Yeah.
I guess.
I could tell you were guessing. Okay. Now, there's various ways to look at this, but in a circle, remember, this is 90, 180, 270, 360, right? Now, we said 180 was equal to what? How many radians? 360 was 2 pi. Remember, all the way around the circle was 2 pi. So 180 would be 1 pi. What's half of 180? 90. So what's half of pi? Half of pi, or pi over 2, right? So then this would be 1.5 or 3 pi over 2. So if you think about it, is 12/19 bigger than 1/2 or smaller than 1/2? Bigger than 1/2, but it's smaller than 1, so it would be quadrant 2. Okay? Another way to do it is just to take 12 pi over 19, this is what most of you will do, and change it into degrees. How do we change it into degrees? Multiply by whatever what?
180 over pi.
Why is it 180 over pi?
Because the thing we're changing it to is on top.
Would the unit we're changing it to is on the top, the unit we're changing it from is on the bottom. Pi's cancel. 12 times 180 is some big number. I don't know. I don't have a calculator in front of me. 12 times 180 is a big number. Divide that by 19, and you get
113.68.
yeah, 113 point whatever. You're just somewhere off in quadrant 2. Okay? Negative 7 pi over 4. Negative 7 pi over 4. You know what I would do if I were doing this problem? I'd maybe find its coterminal angle, because I don't want to deal with the negative angle. So I'm going to find its coterminal angle. How do I find its coterminal angle? Add what to it? Add 2 pi, which is 8 pi over 4. Which all of a sudden this becomes 1 pi over 4, right? If I look at 1 pi over 4, I know that's a fourth of pi. What quadrant would a fourth of pi be in? 1. Because it's bigger than 0 and smaller than 1/2. Okay? If you don't know how to do that, just multiply by 180 over pi. Pi's cancel. 180 divided by 4 is 45. Quadrant 1. Okay? How you do it? Okay. I'm going to call that good. We get out of here at 1:32. So that gives you a little over 12 minutes to work on this. So